Hello students, welcome to Educate. Today we are going to continue with the question number 10.1. This is example. In previous lecture we have studied up to thermal stress and you have a good idea about it. Although here I am giving you quick recap whatever we have studied. We have studied like L equal to L0 into 1 plus alpha delta T, or L equal to L0 plus L0 alpha delta T, or L minus L0 divided by L0 gives alpha delta T, right? So we can also write it as delta L divided by L0. L0 later on we will change. So here L0 equal to alpha delta T. Here what notation is used? So that is L dash is change length, L is original length. So if we use that concept, in that case we will get delta L upon L, and alpha. Alpha is used as alpha L, and when we talk about alpha A, it means we are taking coefficient of areal expansion. So I'm just going to explain that also. So here delta L upon L will give alpha L delta T. So let's analyze it clearly. So here actually the notation that we will make use, so we will use like suppose L0 is original size and L is a new size, or we take say new size as L dash when heat is applied, and this is original. So this is original and this is new, and new means it has become L plus delta L, right? And you know how they are related. So delta L can be found by formula. So this is suppose L dash equal to L into 1 plus alpha delta T. Here one more notation that we change. For linear expansion we write coefficient as alpha L. For areal expansion we write coefficient as alpha A, and for volumetric expansion we write alpha V, right? But in some books you will find that alpha L is alpha, alpha A is beta, and alpha V is as gamma, and they are related by the relations alpha upon 1 equal to beta upon 2 equal to gamma upon 3, or you can say alpha L upon 1 equal to alpha A divided by 2 equal to alpha V divided by 3. So these are basic relations. So here from here if you write L dash minus L divided by L, that is delta L divided by L, you will get 1 plus alpha, sorry 1 will not be there, then you will get alpha L delta T, right? Similarly if you consider area, so suppose A dash is new area, A dash minus A divided by A, you will get as here alpha A and then delta T, right? So delta A divided by A will be alpha A delta T. Similarly, if you consider volume, in that case you will get delta V upon V equal to alpha V delta T. So these are basic relations that we know, but here our concern is to relate alpha L, alpha A, alpha V. So here alpha V is derived, here alpha A is derived. So we are going to study them one by one. So let's see the relation between alpha L and alpha V, right? So for this purpose we will keep in mind that delta L upon L is alpha L delta T, and delta V upon V equal to alpha V delta T, right? So these two things we will keep in mind while deriving. And change in volume. If size is L, on heating it becomes L plus L dash. So delta L will be equal to how much? So L plus delta L, this is new side. So cubing it, we have considered a cube minus original volume L cube. So applying formula, L cube plus 3 delta L into L square plus 3 L delta L square plus delta L cube minus L cube, right? Here this is value of delta. Is it delta L? We are considering change in volume. So it is delta V. So delta V equal to this much. So delta V. Now L cube will cancel out with L cube. So delta V equals, from here, delta L is very small. So square of it will be further small. So we can ignore it, right? Delta L is small, so its cube will be further small, so we can ignore it. So what do we get? 3 delta L times L square, right? Now this is L square. If we multiply by L and divide by L, so L cube will be original volume. So we write here V. So delta V equal to 3 delta L upon L times V. We can shift V to LHS. So delta V divided by V is 3 times delta L by L. Now we make use of these things. In place of delta V upon V, we write delta V delta T equal to 3 times delta L delta T, right? So we will get alpha V equal to 3 times alpha L. So this is our required relation. I think you have understood. Now here we are going to derive this relation. The question says, you can read it, show that the coefficient of area expansion delta A upon A times delta T of a rectangular sheet of the solid is twice its linear expansivity. It means we have to prove that alpha A is equal to twice of alpha L. So let's see in the diagram here it is shown. Same thing I can show you here, that this is original, this is A, this is B. So its area will be A equal to AB. Now if A becomes A plus delta A and the width becomes here, if length becomes, not area, sorry, if length becomes A plus delta A and the width becomes B plus delta B, then new area will be like this. So if you cut here original area, then this is change in area. This portion, and this portion is changed. So the same thing is represented over there. So let's do simple calculation to make it clear. So what we can do, we can start with the original area and the new area we find the difference. So the relation that you will keep in mind, the same thing as we have seen previous relation, so that I will write. So don't worry. So original area, say A, is A into B, right? New area is say A dash. So new side A plus delta A times B plus delta B, right? And if you remember, this is change in length, this is change in length. So same formula can be applied as we have seen previously. So A times alpha L times delta T, right? But before that, it will become complicated if we write this value here because 3 terms will be there. So let's avoid it. First we multiply, or we can directly write a dash minus a. At least one term will cancel out. So here let's multiply. So it becomes ab, then a delta b plus b delta a plus delta a delta b. There is no doubt. Now minus AB. So AB will cancel out. Here we can put the values. So A into delta B means B into, if you remember the formula, what is the concept? When we write L equal to L0 1 plus alpha delta T. So if we open the bracket, L minus L0 alpha delta T. So this is delta L equal to L0 alpha delta T. If we replace this by delta B, so delta B means B alpha L delta T. So this thing I'm going to write here. So A times B alpha L delta T, correct? Plus B times delta, here delta A, same concept. If we replace B by A, so we will get what? B, so this is A alpha L and then delta T, right? And delta A, delta B, both changes are small, so their product will be very small, so we can ignore this term, right? So forget it. Now let's see here. AB alpha L delta T plus this is also AB alpha L delta T, right? So you can say 2AB alpha L delta T, right? And this is delta times A. If you remember, AB means original area. So what we do? We write it here. So delta A upon A equals 2 alpha L delta T. If you remember, I told you that delta A upon A is equal to alpha A into delta T. So here we can write alpha A into delta T equal to 2 alpha L delta T, right? So from here delta T will cancel out and you will get alpha A equal to 2 times alpha L. So we have got this relation also. So finally we can write alpha upon 1 equal to alpha L upon 1 equal to alpha, this is area divided by 2 equal to alpha volume divided by 3. So this is basic relation that we make use. Now let's see this question. Question says, example 10.2, a blacksmith fixes iron ring on the rim of the wooden wheel of a horse cart. The diameter of the rim and the iron ring are 5.243 meter and 5.231 meter, right? At 27 degrees centigrade, to what temperature should the ring be heated so as to fit the rim of the wheel? Means we need this to become this. It means there is length change, so that will be equal to delta L, right? So delta L will be difference of the two, and then what we can do? We can apply the formula, and formula, you know, basic formula if you go, so you can write L equal to L0 1 plus alpha delta T. You can also do by using this formula. L means this length, needed length 5.243, and L0 means this length. 1 plus alpha, value of alpha should be given In the question it is not given, but it should be given, only then we can solve. For iron, it will be 1.2 into 10 to the power minus 5. So we can write value of alpha, right? And then delta T. Delta T means change in temperature. Change in temperature means new temperature minus temperature in the beginning. So T minus 27. So here we write that, and then we simplify. So after simplification, we will get this T equal to 218 degrees centigrade. So I think you have understood. Thank you for watching. Team Educate.